Hello everyone, welcome to Intrinsic Intelligence YouTube channel. Today we are going to discuss in detail non-functional requirements in a system design, which is the basic and the root of any system design. When we are asked to evaluate a distributed system, how it is designed, whether it is resilient, how scalable the system is, non-functional requirement are the concepts which helps us to evaluate any distributed system. When we create a distributed system, we should also have in mind, like when we bring in any new tech stack, we should always consider all these non-functional requirements. We will quickly move on. So these are the basic non-functional requirements which I have given here. There could be other non-functional requirements, but when these basic non-functional concepts are incorporated, our system will be resilient and it could be scalable, it could be maintainable, it could be highly available, and it is fault tolerance, and we also ensure the security of the system. So availability, reliability, scalability, maintainability, fault tolerance, and security are the basic non-functional requirements which we have to consider while designing any systems. So first we'll move on into availability. So what is availability? So availability in general are evaluated in terms of nines. So 99.9 and the 9 adds 99.99, 99.9999. So the number of nines are used to evaluate the system availability. So it is the percentage of time where the infrastructure is accessible to the client under normal conditions. If the service is 100% available, it is being said that it is operating at all the times throughout the year. So how do we measure availability? Here is the calculation. Total time minus the amount of service was done. So consider for an year as a total time, like amount of time the system was down. We can consider it in seconds into 100. So which will give us the value of nines on giving us the number how much available the system is. So this is where when I started the discussion, I brought in like number of nines. So if the system is 1 9, then it is like downtime per month is 72 hours. So downtime per week is 68.8 hours. So when we go to the best available 99.99999, it is like 5 9s or 6 9s or 7 9s. There are downtime, if you see for the 5 9s, it is 25.9 seconds, and for the 4 9s it is 2.59 seconds, and for the 5 9s it is 0.259 seconds. So the downtime per week is also in seconds. So this system is with 5 6 and 7 9s are very much highly available. We will move on. Now, next is reliability. Reliability is the probability of the service or in a specified time, how reliable the entire system is. So we have a system at large scale, and how we can say how much it is reliable. There are two factors we can calculate this: MTBF, mean time between failures, and MTTR, mean time to recover. So how it is calculated? Mean time between failures is total elapsed time minus downtime by number of failures. So MTTR is total maintenance time by total number of repairs. So it is these are the two different factors where we can evaluate and say how much reliable the system is. Next is scalable. So scalability in the real world is much needed. So now when we create an application or a mobile app, the number of users can grow at very large scale. So when the users grow, how easily or quickly or within a quick turnaround time we are able to scale the system. That is much important. Consider an example of a search engine. Consider an example of a chat system. So if there are any events occurred, consider the number of tweets on a particular hashtag people will do. If a celebrity posts some video, how quick there are comments, there are likes, so things like that. So the workload can be classified into request workload. Either the system can have more number of requests can that than we anticipated, or it could be data workload, the amount of data stored in a system. So consider in a social media, we are posting a videos, text, images. So in that case, it could be data workload. Consider in terms of a request. Suppose if we have a system of a search engine or any such system, we have keep on hitting the APIs more and more. So the workloads can be defined as request workload or data and storage workload. So in these two scenarios, the system are requested or expected to be scaled at large. Maintainability. Besides building a system, we need to maintain the system, fix the bug, add new functionalities, and improve the platforms, upgrade the tech stacks. So maintainability is one of the vital or a complex requirements we have. So the maintainability can be further considered or divided into three aspects. One is operability. So consider a system is there and how we are making it operational throughout. So there are activities under the normal conditions it has to work. So under normal conditions we have to make the entire system operable. So this is operability. Lucidity is how the code is easy to read and maintain. So the code should be simple. So in that case, we'll be able to maintain, fix bugs, bring in new features. So that is lucidity. Modifiability, this is a capability of the system to integrate new or unforeseen features without any hassle. So modifiability meaning if we are suppose we have a system and we are planning to bring in a queuing system or a notification service, or we need to bring in any catch, or we need to add any component into the platform. So this comes under modifiability. So the maintainability can be further classified or divided into operability, lucidity, and modifiability. Fault tolerance. Fault tolerance refers to the system's ability to persist even if there are one or more components fail. So consider in a real world scenario where we have thousands or lakhs of nodes across geological locations. We have CDNs closer to the user's location. So when the system goes down, and how soon we serve the customer by the other nodes, or share the workload with the other nodes, or bring up another node and then attach it to the uh, fleet of servers. So fault tolerance is like how quickly we identify the issue and how quickly we recover from it. Security. So consider like security can be any data breaches, denial of service attacks, or it could be on the data privacy. So when we are designing a systems of any payments, banking or insurance, so we can go consider for GDPR, Global Data Protection Rights, or HIPAA, Health Insurance Protection Act, or CCPA recommended organizations. They have a process to be followed when we are building the systems. In terms of data privacy and compliance, these are some examples, and there could be other procedures and policies which could differ between countries or continents. Or it could differ on industries as well. Banking could have different and insurance could have different. So we should follow that. And in case of any cyber attacks like data breaches, hacking, denial of service attacks, the system should be efficient to handle all these factors. So these are some of the basic non-functional requirements we need to consider while developing or designing any system, or given any system we are going to work on. When we need to evaluate at first, we should consider all these factors to evaluate that particular system. The first one is availability, second one is reliability, third one is maintainability, fourth one is fault tolerance, and then the fifth one is security. Thank you all for watching this video. Have a very good day.